to paint it. How the you are painting it, there are two types of painter. One is paid painter and the free painter, and this you will be using to paint all these wall. And look, there's some time array and cost array. Like this much time the painter needs to paint the wall, and this much cost you have to give the painter, okay, kind of thing. But this is only for paid painter. Free painter is actually your friend. So what it does is it paint any wall in 1 second with zero cost. Doesn't cost you anything. So paid painter has this restriction of time and cost, that okay, he will paint the ith wall in time I and cost I, sorry. Yep. Now how do you use the paid painter and free painter to paint all these walls? Okay, so the best thing you could have done is that okay, go free paint all the walls, but that cannot be done because the constraint and the problem is that free painter can only be used only if paid painter is occupied. Paid painter is already occupied. So yep, so that is a constraint. This free painter is bit, yeah. So he doesn't want to work until and unless the paid painter is already working. So what I need now, that okay, these many walls are there. Paid painter, you go and take some walls, okay, 2 3 walls, okay. Now the first thing which you need to figure out for this problem is, okay, is it greedy or is it not? Can I say like why? What I'm saying is basically like I said that okay, the paid painter, I'll give them 3 walls out of, let's say, n is equal to 10. So I give them any 3 walls, just go and paint it. Would be the any 3 walls, or is that like any greedy thing related to it? Key only the such walls that have maximum times, only such walls that have minimum cost. Those 3 walls or those three, right? Based on that, or some mixture of that, or is it like we have to go for each combination of 3 walls? So that okay, let's try with the 3 walls and then yeah, see. And yeah, so that was it. So but the problem, like now you got it, like okay, free painter can only be used only if paid painter is working. So they basically the complete set of walls will be divided into two set. One is set in which the paid painter is working, one set in which the free painter is working. Both are working simultaneously, and obviously this paid painter set, you don't want to make it big. You don't want to like give him so much money, and you don't want that they should have some cost. So what you want, that this paid painter wala set should have minimum cost, but you cannot make it empty. You need to make it something which is able to like allow you to just get your free painter working. So how much you need this? You need this so that the time that it stretches out, okay, the time that this set of paid painter stretches out should be greater than or equal to the time that free painter set has, like the yeah. So like you have to choose some of the walls and give it to the paid painter so that he will take that much time to paint those walls. Abhi, I'm not discussing about cost because yeah, I want to minimize the cost. That is the ultimate thing. But the constraint of the problem is that at least the time that he should take, paid painter should take in this set, completing painting this set of walls, should be greater than or equal to the other remaining walls, like which are not present in the paid painter set. Let's call it the other set, okay. And you can say everything other than the paid painter set is of free painter. Now the time that it should take for paid the other walls should be lesser or equal than the paid painter that should take, because then only you can use the free painter. So now it becomes like okay, you have some set of walls, you need to choose a subset of walls, okay. When this question came, choose a subset of something, okay. We are getting there. And already we have discussed that greedy is not work, like to give him, let's say, three set of walls, which is having least cost. No, it would not work. Which is having maximum time. No, it will not work. You have to basically yeah, take the counter example and see like why it will not work, and then you will say ki, okay, grid is not working, we have to try for all combination of possible subsets. So then I choose any subset. I say that this subset, you paid painter, you will be working on this subset. So he will take, okay, how much time do I need to complete this subset? Okay, that time I got. And how much cost is my basically the potential answer if the time satisfies the condition validity. So now this is the cost and this is the time. Now if this time is greater than the number of remaining walls, because those will be painted in that much time, right? 1 second, one wall, which means like the number of walls that are remaining, that much time it would take, right? So this time should be greater than the, so what I need is that okay, this set, how much time does it take? It takes like the summation of ti values, because this is what paid painter is painting. He does not paint it in one time, he paint in ti time. So the subset which I have chosen, the summation of ti values in that, okay, should be greater than what? The remaining walls, just a number of walls. Okay, so what you need is now two things. Basically, the remaining number of walls can be written as total number of walls minus the walls that paid painter is minus set dot size, like whatever the size you have given to paid painter. Okay, so basically what you want, that your time of the paid painter should be greater than n minus size of the paid painter. Okay, size of the paid painter set, let's say paid painter set is p set. Okay, so the summation value of p set, basically p set time time value of the p set should be time ka sum of p set should be p sum of p set should be n minus p set dot size, something like that. Now, because these are the remaining number of falls. Now I could have taken this there and this. So I want such a subset whose size plus whose summation of time values is greater than or equal to n. Now how do I get this now? So iske liye, first what the mistake which I was doing ki, like let's say that I was using three state. One is the summation of time, one is the number of elements in set, number of in p set, number of element in p set, and third was id, which is generally there. But even if you don't understand why this is, but the problem is that these two things should not be there. Like as a state, you are having state as summation of time and the number of elements in p set. Like that's what I was doing, because based on that it matter ki you are standing on id. This is the time which the you have like already in your subset, which you are p set, and this is the number of elements that you have in p set. Okay, NPS, and the other things are C and P, which helps you to take. Now the basically the only two option, how I create subset, a kind of things key, take all possible subset, take or not take. So you go to ID plus one and say like taking or not taking, right? So these are the two things which I did. And what are the like ending point? Ending point is equal to id becomes equal to n. Okay, then I need to check key. Okay, now everything is fine. So the summation of tn plus nps should be greater than or equal to n, or whatever I can say ki if at any point ki hamara tem plus nps becomes greater than equal to n, to return 0. The better way is that कि यहाँ पे भी रिटर्न जीरो कर सकते हैं, यहाँ पे भी रिटर्न जीरो कर सकते हैं, बट अगर ये नहीं होता है, ठीक है, else what we can do, we have to return 1e9 कि भाई you're not able to, yeah, with this set, ये this set नहीं चलेगा और इसकी कॉस्ट इनफाइनाइट है, ठीक है, इस सेट से तुम काम ही नहीं कर सकते, ठीक है। तो वो बात है कि कॉस्ट इसकी इनफाइनाइट है, और यहाँ पे जब तुम टेक नॉट टेक करोगे तो टेक में तुम कॉस्ट को ऐड करोगे, सो सी ऑफ आईडी को ऐड करोगे, आईडी प्लस वन पे जाओगे, तुम टीएम को बढ़ा दोगे अपने टी ऑफ आईडी से, अपने सी एनपीएस को बढ़ा दोगे प्लस वन से, बिकॉज मैंने एक और पर्सन को यूज कर लिया है प्लस वन। सी और टी तो कांस्टेंट है, कांस्टेंट की तरह चलेंगे। नॉट टेक में तुम्हारा आईडी प्लस वन रहेगा, टीएम रहेगा, टीएम सेम रहेगा, देन तुम्हारा एनपीएस सेम रहेगा, और सी और टी सब सेम रहेगा। तो दिस वाज द इशू व्हिच आई वाज डूइंग कि मैं तीन चीजों को ले रहा था, सम, और मैं डीपी में सॉल्यूशन डीपी ऐसे लिख रहा था कि इफ डीपी इज dp of tm, फिर n ps एंड id इज इक्वल टू नॉट इक्वल टू -1, तो ये नहीं चलेगा, ठीक है। अब क्या चलेगा इज दैट कि इन दोनों को हम मर्ज कर सकते थे एक चीज में, ये दो स्टेट नीड नहीं है, मेरे को एक सबसेट का सम प्लस उसके एलिमेंट्स को एक साथ देखना है और उसको ग्रेटर देन एन रखना है। तो मैं क्या करूंगा कि व्हेन आई एम डूइंग दिस ना, टी एम इज इक्वल टू टी एम प्लस आई डी, कि भाई तुमने इतनी वैल्यू ली प्लस तुमने एक ले लिया, अपना साइज भी ऑक्यूपाइड, हर बार जितने एलिमेंट आ रहे हैं उतना ही साइज हम बाद में ले रहे हैं, एनपीएस में प्लस वन कर रहे हैं, तो एनपीएस प्लस वन करने से अच्छा तुम यहीं पे प्लस वन कर दो, कि इतना टाइम तो तुम्हारा ऐड होता ही जा रहा है, होता ही जा रहा है, बट उसके साथ साथ एक एलिमेंट और ऐड हो रहा है, एक यूनिट और ऐड हो रहा है, वो साइज का यूनिट ऐड हो रहा है, ठीक है। सो टाइम प्लस साइज, अगले का टाइम प्लस वन, अगले का टाइम प्लस वन, अगले का टाइम प्लस वन, तो चार एलिमेंट लिए मैंने। तो ए वन ए टू ए थ्री ए फोर, या फिर टी वन टी टू टी थ्री टी फोर। तो पहले मैं क्या कर रहा था कि मैं पहले देख रहा था कि अच्छा तुम्हारे चार एलिमेंट, तुमने टी वन लिया, सम इज इक्वल टू टी वन, नंबर ऑफ एलिमेंट इज इक्वल टू वन, T1 plus T2 number of element is equal to 2, T1 plus 3T number of element, तो एट लास्ट जाके मेरे को सम ही करना था, तो इससे अच्छा क्यों ना मैं T1 plus 1 ले लेता और T2 plus 1 ले लेता और T3 plus 1 ले लेता, तो सेकंड वाली चीज की मेरे को नीड नहीं पड़ती। दिस वाज द होल प्रॉब्लम। और फिर केवल इस पहली चीज से अब देखते हैं होड़। सो दिस इज द पहली चीज, लाइक नॉट दिस इज द वो चीज, मतलब बेसिकली समेशन है तो इसलिए 1001 ले लिया। ID and TC is basically you can say the summation of time of the complete set, which is TC plus TID plus 1 कर रहा हूँ मैं यहाँ पे। दिस वाज द मेन थिंग। एंड इसमें तो नॉट टेक है, तो मिनिमम ऑफ टेक का मैं नॉट टेक की एलिमेंट लो या ना लो, और मिनिमम ऑफ टेक नॉट टेक ही होता है सबसेट बनाने के लिए। एंड देन इसमें जैसी कंडीशन ट्रू आती है तो रिटर्न जीरो, कि लाइक अभी मैंने इतना सबसेट बना लिया है कि उसका जो समेशन ऑफ टाइम है प्लस उसका जो साइज है इट इज ग्रेटर देन n, सो विच मीन्स लाइक या बाकी सारे जो पे फ्री वर्क है दैट कैन वर्क। एंड या दैट्स व्हाट इट इज यार मैन, सबमिट कर दिया था मैंने। So the problem was really just about choosing an optimal subset to give the paid painter so that free painter can work on the remaining part. Now the optimal subset should be like that कि उसका जो sum है plus the number of values in it should be greater than the number of remaining values, क्योंकि remaining values is equal to the number of time, like is equal to the time कि बाकी सारे walls कितनी देर में paint होंगी। So मेरे को इतना time यहाँ पे लग रहा है, तो हाँ this was the thing. Okay bye.